So students, we are doing questions from Concepts of Physics by HCVERMA, Volume 1, Chapter 3, Rest and Motion Kinematics, and we are doing this question from Objective 2. This is the third question, students. Pick the correct statements. A part. Average speed of a particle in a given time interval is never less than the magnitude of the average velocity. Each of these A, B, C, D we have to analyze and we have to choose which are all correct. So let us analyze, students, A part of the question. A part of the question is saying like this, that average speed of a particle in a given time interval is never less than the magnitude of average velocity. Let us take a complex case in which a particle went forward and after a certain time the particle went backward. So let us say the forward distance is d and backward distance is also d. So average speed is given by say 2d divided by, let us say, total time taken is t. Average velocity is 0. This is a case in which it is saying that it is never less than, it is greater. This is greater. There is another scenario in which the particle has covered. Let us say here it is d and d. In this case, average speed is 2d by t, and average velocity is also displacement 2d divided by t. So we are seeing the cases in which that now the average speed can be only at most be equal to. It is never less than. Can never become less, because distance will always be greater than or equal to displacement. Therefore, first statement is correct. Now let us look at the second statement. What is the second statement saying? B statement. Is it possible to have a situation in which let us understand this dv vector divided by dt? What is the meaning of this? This is velocity, and the rate of change of velocity is nothing but acceleration. So here he is asking that, is it possible to have a situation in which acceleration is not equal to 0? Acceleration is not equal to 0, it is mentioned. And what is the meaning of the second expression, that is magnitude of this velocity is speed. That is d by, this expression means that equal to 0. This means that speed is constant. Is it possible to have a scenario? Yes. How? For example, if a particle is moving in circular motion, if a particle is simply moving in a circular path, this is a circular path. In this, if it is moving, we know that there is always a centripetal acceleration towards the center, which is given by v square by r. This you may learn in the later chapter, but you can imagine that there is an acceleration only towards the center of the circle. And what about the speed? Speed is constant. Speed is constant. Therefore, its rate of change of speed is 0. That is possible. That is, acceleration is never equal to 0, and and speed variation is or speed is constant. It is possible. Therefore, we can say that the statement B, is it possible to have a situation in which acceleration is not equal to 0? If speed is constant, yes, this is possible. Circular motion. C part. Average velocity of the particle is 0 in a time interval. Is it possible that the instantaneous velocity is never 0 in the interval? Let us take once again for this case also, C case also. The C case is asking us very clearly that the average velocity of a particle is 0 in a time interval. Let us take again a circle. Say the particle is going like this. This is the initial point and this is the final point. Please understand what is it. Initial point and final point. When a particle is making a circle like this, a rotation like this, then please understand it is saying that average particle is 0 in the time interval. If you are from the initial point, you started and you came back to the same point, then the average velocity is 0 in say time t. Instantaneous velocity is not at all 0 in this interval because it is moving at constant speed there. So this is also possible. Next is the average velocity of a particle moving on a straight line is 0 in a time interval. Is it possible that the instantaneous velocity is never 0 in the interval? I want to demonstrate through a simple example, students. See, this is something which I am throwing upwards and I am catching it back. So the displacement is 0. Therefore, average velocity is 0. Instantaneous velocity is never 0? No. At the topmost position, at that point, instantaneous velocity is 0. Therefore, this D option which is saying that average velocity of the particle moving in a straight line is 0 in a time interval, yes, possible. Is it possible that the instantaneous velocity is never 0 in the interval? No, that is not correct. So, we can take, what is the example we can take? Through the example of motion under gravity, I am able to say that particle projected upwards and coming down. When it reaches at the bottom, average velocity is 0. And here at this point, instantaneous is equal to 0. Therefore, we can say that the C option or D option is not correct. It will be 0 in the interval if it is in the straight line. I hope you are able to understand this, students.